My name is Nico Heidtke. I'm here to talk today about what I call growing pains. In German, it's Wachstumsschmerzen. Subtitle being lessons from seeing C++ code bases mature. And this is a topic that is very close and dear to me and has become so even more in the recent years. Before I talk what precisely I mean with that, I want to introduce myself a little bit, so you know why I care and from what perspective I speak about this topic. So I've been told I don't look like it. I guess it's a compliment, but I have around 24 years of programming experience. That is because I started very early in my early teens with Quick Basic. Actually, I was 13 with programming, and I picked up C++ when I was 16 to do game engine development. And this has stuck with me for quite a lot of time. I don't do it anymore. I haven't been doing this for 10 years now, at least. But this is where I started with C++. I'm still interested in that a lot. And actually, randomly, someone in the online audience today is actually a school friend of mine from school that I programmed a lot games. So, hi Sebastian, if you can see me. He wrote me an email when he saw that I will have a talk here today, so I'm happy that we can reconnect by this way, and we might do that. So, and since then, I've been working across various roles in various programming languages. I would say about 50% of it was C++, but there's also a lot of Python and C# and Kotlin later on, and even Elixir, a lot of stuff. I also worked in various roles. I've been a Scrum Master for half a year on the side. I've been managing teams for like 10 years now. Been in software architect roles for even longer. And so I can say I care a lot about software development. It's my passion. And I've worked at some very interesting companies and some more boring companies. In one of those companies, I actually was employed as a software architect and team lead for a while, and I've been sent to be part of the due diligence when the billionaire founder of the company needed somebody to look into source code of startups that he was interested in investing in, and or outright acquire for his own company. And I was already a reputation as a code reviewer, and I just said, yeah, I do that. I have fun looking at code of other people's and making judgments. Even though I didn't do that before, but I thought, hey, it's cool probably. So I've seen a lot of code bases, different code bases from startups and from young people specifically, but then also some older code bases that, of course, grew. And my experiences and the lessons that I've learned from that about how code bases evolve and the people working in the code bases is what I want to talk about today. So actually, this was the next slide. So one thing that I've seen is there's things that if you have little experience, especially if you're in a startup or if you're just a young developer that is starting out with C++, that you probably should be prepared for, but you really can't be well prepared for unless you have experience already. And so I want to be today here and share a little bit of my experience in a broad overview, actually. So it's not going to be a technical deep dive on the C++ features. I'm going to stay on the surface level for a lot of things. And that is because the people that I hope to talk to are in those categories here, mostly. I guess some senior developers, experienced seasoned veterans can also learn something here maybe, or just refresh something. But who I really hope to reach is people that don't have a lot of experience in the C++ ecosystem in general, or maybe just in a part of it, but not a bigger overview. And so it might be somebody who has been programming C++ for a long time, but really didn't care about external dependencies as much because they're just writing code, algorithms, mathematics, for example. Or maybe it's somebody who was forced to switch into C++ while having a lot of programming experience in another programming languages. I have friends like that, and I've seen people needing to pick up C++, and I think there's a few things that you can pick up early if somebody told you about it, and then do a little bit better and do right from the beginning. So this is my target audience, essentially. let's say, well, you're creating a new C++ code base. And there's a lot of questions that present yourself, but the very basic thing and why you are starting a C++ code base in the beginning is, well, you have a problem. And that problem needs a solution. Might be a business problem, might be a personal pet project of yours, but you're trying to solve a problem. And that's where all the focus is initially, where all your attention is. And eventually your project and your startup might become successful, and there's going to be new demands just beyond solving the immediate problem. Actually, Peter Muldoon's talk from before was a really good introduction kind of to my talk, I believe. And I don't know if he's here, but I hope he is. Maybe he sees it later. Really great talk. And so your project succeeds, your code base grows, your team grows, and there's going to be new challenges. And you need to address those challenges. And probably when you started out with a great idea, just a few guys out of college, for example, with a startup, you haven't worried about a lot of those things. But if you didn't, and you will then have to face technical debt challenges that accumulate. And from shortcuts that you took, or maybe it's not shortcuts, it's just inexperience, and you just didn't know a few things that you maybe should have known. I was talking about challenges with growth in general. So one major challenge, obviously, is that the code base grows in complexity, and complexity is always a bad thing. But also, it's people. There's the onboarding. Peter Muldoon also spoke about that. You need to onboard developers on your team. It could also be an open source project. There's contributors that join in. You need to align with these people. There's different mindsets and opinions on various things, and a lot of friction that is created because of that. And somehow you have to find common grounds, a common language, unified language, as was said before in the talk, to be able to work together effectively. And a lot of startups that I've seen or young code bases are really not well prepared for that and struggle. And there's going to be technical debt, as said, and it needs to be managed and reduced. There's this quote from Abraham Lincoln that I like very much. There's different variations of it, and I don't know if it's really can reliably attributed to him, but I've seen that a lot. Give me 6 hours to chop down a tree, and I will spend the first 4 hours sharpening the axe. And I think that's a good mindset. I think any task that you set yourself out to do, you should be well prepared for, and you should use the right tools. And this funny graphic here, which I think is very well known, also fits into that category for me, where, well, you should better be knowing what you're doing, and you should sometimes stop and consider if there's a smarter way of doing something that you're doing. And I'll try to do that today to give some input. So this is a quick overview about a selection, really a selection. There's much more that I could talk about, but I had to limit myself, and we see if we can get to all of it, where I want to give a quick insight and a few recommendations on what you should be prepared for if you're running and have a growing C++ code base, what you should be prepared for, or what you can prepare for, maybe you don't need to deal with. Which isn't going to be a problem when you're starting out and are small, most likely, but can be a big problem if you grow. So, first problem, very basic one. It's code-based layout, very simple one, and some conventions that come along with it. It's really, if you start with a code base, it's one of the first major decisions, and I think it's an important one. You can often change that later on. But if you're big enough, then a few things about your code base might not be able to change anymore. So you better have a good setup. Otherwise, you just have to invest a lot of work to fix it again later. Also, if you think about a repository, that's really the first impression that your code base makes on anybody. This is especially important, at least for me, for open source projects, where people join in on their free will. So if they look at it and it's messy, people might not want to work in it. You might lose contributors, and of course you yourself might have a hard time working in your own code base if it's a mess. And the C++ ecosystem, that's something that is surprising to developers from other ecosystems. doesn't have much guideline or conventions historically for setting up a C++ code base. Like you can put your include and source file folders anywhere. There's different documentation standards, different build generators, and how they organize their files, and everything is optional, everything is configured. And it's gotten better. There's a few things that are a little bit more, not standardized, but more common now. But just to make give you a little bit of a nightmare, it's a fictitious example, but you can have code bases from people that just don't know the C++ ecosystem well and have not much experience that look like this, where everything, or a lot of things are in a flat hierarchy. So here's a reduced example, but there's dead code in there. There's seemingly no naming conventions, no documentation, a mixture of generated build files and manually maintained build files. You can have a lot of bad problems that will hurt you in the long term. The stuff might work, but if it grows, this will become a problem if people join. And you can do it better. I'm not saying this is the best thing or this is exactly how you should do that, not by long shot, but there's people that have spent a lot of time and energy into investing how a code base layout could look like. There's Jason Turner's CMake template, for example, a pitchfork layout. Really doesn't matter as much what you choose. It's just, I think you should align yourself a little bit and it should be logical, intuitive, discoverable. I have a few general tips here. For example, that third-party dependencies should be separated well from your own code in your C++ code base. I will talk a little bit later why that is really important. So just clean up your code base layout and make it nice. It's easier to work in and people will join happily. That's my first recommendation. Another thing that obviously becomes very important, I spoke about documentation, is, well, the general topic of knowledge transfer and documentation overall. Really won't matter that much when you're small. I've seen multiple startups that consist of 3 guys from the college that are best friends, maybe even, and they're pretty much aligned. But then the same startup grows to the size of 200 people, and then this won't work anymore. You will have to write a few things down, especially in C++, unfortunately. I think it's a very documentation-intensive language because you can do so much crazy stuff. There's so many different software architectures that you can have when you write C++ code. And that necessitates, in my opinion, that more things need to be documented, and especially when the team grows. You have people leaving your project then, if you're successful and your project is big, and they take knowledge with you, and you better hope that they don't take knowledge with them that only they have and that is not written down anywhere. This exists, and it's a big problem and a big risk for a company, and documentation can help with that, and of course, reducing technical debt in general. Onboarding process, of course, will get easier. I had a very nice experience where onboarding on a company was a struggle because everything was verbally communicated, and once you write down a few basic things, then you can have people work in asynchronously. Nobody has to talk to them. I mean, probably people should, but they can get the very basics out of some documents and can get working within a few days, ideally. And that helps. And of course, there's going to be arguments about code formatting and this and that. And if you just had those discussions before and you write down, okay, we have decided we do it like this because of that, that helps to save time as well. Here's a slide about different kinds of documentations that I think are relevant in this context particularly, and that is software architecture documentation, so decisions that you made of how your software product is designed and how it works. That is, I think, really important to be written down because there's probably a lot of energy that was spent on making those decisions and coming up with good designs. And a little bit more energy of writing that down doesn't cost as much, but I think it delivers a lot of value, at least if it doesn't change a lot. And there's code documentation, which should probably be close to the code, so comments in code. And then there's, as I said, guidelines about how you work, what tools you use, how your code review process looks like, and how you deploy maybe. That should also be documented, I think, at some point. Yeah. Maybe a few other recommendations that I haven't spoken about yet. One thing that I've seen really bad, and I'm sure a lot of people have had the same experience here, is if documentation is placed far away from the stuff that you're documenting, out of source control. When you think, okay, I'm documenting my software now, and I'm putting all the documentation in, I don't know, in a Word document, and put this on a shared folder somewhere on a Windows shared drive. Even a wiki, it just goes stale. I've never seen a wiki in my life that doesn't have like 90% of content after a few years that just doesn't apply anymore and is outdated and is not maintained. This happens also with comments in code, obviously, but to a lesser degree. And if you have a documentation in source control, it can change along with the stuff that you are changing. And people also forget it less easily. So that's my recommendation. README files for projects, we spoke about code-based layout, are really also very important, and I really like Markdown. As I said, it's not like you have to use this. I'm just telling you there's options that you should look into, and this is what I like. I write almost everything in Markdown nowadays in terms of documentation. It's a little bit limited, but sufficient for most things. Yeah, and a word of caution, this also applies to tests, which I will not talk about here today, but if you have something in your software, in your code base that is still changing a lot and all the time, you might not want to document it as much yet or at all, because you will just get frustrated with having to maintain it all the time. But as I said, software architecture, things that are stable and that well tested, that won't change as much unless they have to, you probably want to document those. Another thing that's really important that what I observed is your development tools, which ones you're using and how you use them. I think a lot of people also here spoke about automation already a lot. Automation is great. Tools and hardware and software really scale really well. People not so much. So there's a lot of things that you can automate. You can use static analysis, for example, to catch issues that your code reviewers just can't catch all of them. Code reviewers can catch stuff that static analysis cannot catch, but tools can, vice versa, static analysis can catch stuff that your code reviewers likely won't catch, or at least not all of it. And you can use tools, various kinds of tools, to enforce standards in your code base. Consistency and standards are always nice. So I will go over a few tools that you can use. And the tools are also become very important eventually when you come to the point where, let's say you are a startup and you want to sell your software, then, let's not go here yet. Then there will be new requirements in terms of software security and reliability and also compliance topics. And if you do everything by hand without tool support, you will suffer a lot because customers might get updated, might want to get updated lists of software licenses or a vulnerability report on the third-party dependencies that you're using. And tools can help a lot with that. Here's a quick overview, it's not a complete list, of I think what are important tools that you could use in your code base, and you should probably consider using some of them from the beginning, if not most. There's code formatters, for example. I spoke a lot already about static analyzers, dynamic analyzers, so address sanitizers, undefined behavior sanitizer. And then there's build generators and code generators. We have different options there. You can, of course, write everything by hand and maintain it, but probably use a tool for that. Testing frameworks and package managers, which is something which isn't that easy or straightforward in C++, but I've been working with Conan for the last year, Conan 2 specifically, and I think it's great what they're doing, and I'm a big fan. I know package managers from many other ecosystems, from other programming languages, and I'm happy that they get more proliferation in C++ as well. Just one story here that I thought I inject here. Warning fatigue is a not uncommon problem. I want to talk a little bit about what that is and how that happens. So let's say you have a static analyzer that you use in your code base, and at some point you enable a lot of warnings because you want to be a good engineer, and then there's delivery pressure. There's not much time to fix warnings that are reported, and then you just ignore them. And then there's like 12 ignored warnings in your code base. And then the next engineer comes along and creates the next 10 warnings, and he sees, okay, there were ignored warnings before, now there's 10 more. Maybe it's not so bad, we can do that next week, next month, or whenever. And all of a sudden, you might have code bases, and I've seen this, with thousands of ignored warnings. And nobody looks at them anymore. And then there's some serious problems that slip in there. It might be like an access to an uninitialized variable, hiding behind a lot of potential divide by zero errors, where you think, not going to happen. We don't have inputs where this happens, so I don't need to care about that. And then you might have some trouble, and you will have bugs because of that. And at some point, somebody gets annoyed and says, I don't want to see those 2,000 warnings. I just did disable all of them, or that group of warnings. That's not good, obviously. So my recommendation is just don't let this happen. If a tool reports a problem, just fix it immediately. Or if you have to ignore it as locally as you can on the site where it happens, or maybe for the sub-project, but not globally. Just don't ignore it. Otherwise, this will happen. There was also a great talk yesterday from, I think his name is Philip Schubert, the notorious BOG, where he talked about the static analyzer of his company, which is Sonar, which probably a lot of you know. And he just threw the slide on the wall where he showed the most common problems that they found statistically in the code bases of their cloud customers. It was very interesting. A lot of stuff is very trivial, and we'd think people just shouldn't make those mistakes, but people make mistakes. So static analyzers are great. They find the stuff for you, save you a lot of time. I would always use one, or multiple even, because they're not covering all the same stuff. Code formatting is another big thing, which I think is worth talking about on its own here. You have to be aware that, as I said, if you start out small with a small code base, alignment is rather easy. Everybody has their own area, or maybe you just agree on the basic things. Otherwise, you wouldn't have started your a project together. But when people join, there will be different opinions. And I've seen fights and repeated discussions over the same issues over and over again. I want my credit bases on this line, and you want it there. Tabs versus spaces, lots of things. And I hate those discussions. You cannot make everyone happy. You can make everyone unhappy, I guess. But you cannot make everyone happy. So when I set up a project, I would recommend just start out with a code formatting tool and a guideline. Just pick something that you like, as the owner of the project, and just follow through. You might have some exceptions later, and different rules for different parts of the code base, maybe where different ownerships allow that or should do that. But I would not start without a code formatter that just dissolves all the most of the fights that you have. You will have fights over rules still, but a lot of friction will be gone because people will just join the project, new hires, and they will see, we're using code formatter, we're using the, Mozilla code formatting guide, and that's just what is being used here, and there's no sense fighting it. That's my recommendation then. To summarize, use tools for repetitive tasks. You can write your own tools. I've done that a lot, and I've seen that a lot. There's just some things where standard tools don't exist, but that are really useful to be automated. Write your own tools if you really have to, but always look for a known and standard tool before. I would recommend static analyzers and also dynamic analyzers. Really, really cool. They really, really help. put in a high warning level also on the compiler, treat warnings as errors, and take care of them immediately. And use the code formatter. I think it matters. Next thing, external dependencies. This is closely related to the codebase layout issue that I spoke about earlier. I think this is also some notoriously underperforming area of C++ where there are so many different ways historically to include third-party libraries, and libraries had so many different layouts and looks and how they're being built and what they expose historically. It's also gotten better. That this is really badly or not standardized at all. But I think it should be, because it's really easy to do some really, really stupid things in the area of external dependencies. And I've seen many young code bases and startups do those mistakes. And those can actually become legal issues. And I talk a little bit about that. And you will eventually you will have to do it right. If your project is going to be successful and big, you will have to do that right. There's just no choice. Otherwise, you get sued, and you will not be able to grow. So, what are some of the worst mistakes that I've seen? And I've seen all of this. I've seen actually all of this in a single code base at one point even. So, you pick up a third-party dependency, some library that you want to use, and maybe you look at the license, but you don't understand it, or maybe you don't look at the license, and sometimes project licenses change and you don't notice. Tools can help with that. But let's say a problem is you don't really take the license of whatever you're using into account really well. And I've seen this happen where some startup then all of a sudden they had to remove one of their major dependencies from their project, and they were really struggling with that. And you don't want to be in that situation. So if you use something, be aware of the license terms. So also I've seen parts of other libraries being copied in directly somewhere straight into, in parts, into your own code base, where then it's not clear that this is a third-party dependency. Unless you use some really advanced tools like Black Duck, you will not be able to even know that easily that it's in there. Don't do that. Keep your third-party dependencies separate from your own code. It gets even worse if this third-party code then is modified. I've also seen that. So you think, oh, there's something that I want to have different in this third-party library. I copy the code in my code base, and then I change this here and add an interface there. And then the lines between what's yours and what's theirs is become blurry. And I guess lawyers love this because it gives them work, but you shouldn't. I've also seen people disable warnings and compiler warnings and static analyzer warnings in their own code because of some third-party library that is hanging around somewhere. Don't do that. Just isolate that and don't let the analyzer run over there, or maybe fix it if you can. But and then also in the Windows world, at least, that's a very common problem I've seen. You have pre-built binaries, and a lot of people used to just pre-build them on some machine. No, there's Tim on his developer workstation on Windows, and he pre-compiles this library and then takes the DL and the lib file and some headers and just pastes them into your Git code base and just commits it and then says, yeah, we can use it. And then this is what your project is built on for the next 2 years. Not a good idea because it might not be reproducible. Tim has left the company, and nobody knows with which flags this thing was built and which version exactly, and you have to reverse engineer all of that. You don't want to be in that situation. And as I said, I've also seen this very recently. You go into a regulated market and you sell to some serious customers, and they're going to ask you a question like this. We want to have a software bill of materials for your software product. Otherwise, we're not going to buy it. We're not going to integrate it in our own software. And you're better prepared to be able to deliver that and update that regularly, hopefully in an automated fashion. And so you can regularly review licenses and also scan for security issues so you know when you need to update the license. There's great tools for that, to do that, and you will have to use them eventually. If your project gets to a certain size or into certain business areas, you will have to do that. So you might think about that already from the start. Yeah, again, to summarize, those are my recommendations. keep your third-party code really separate from your own code. Avoid modifications. And if you make modifications, do it in a fork. And if you need to pre-build stuff, then use a package manager. Submodules are probably okay for open source projects. I know that's become using. There are some issues related with that, but it's mostly okay. But I think the best thing that you have is using a package manager, because they come with tooling to help you collect licenses and transient dependencies, and it's really, really nice if you are able to do that. But of course, that's work. So eventually, you probably should do that, but maybe not from the start. And maybe as a final tip, because it transitions nicely to the next slide, you probably want to abstract from third-party dependencies quite often. And let's talk a little bit about that. So abstractions. Now it gets a little bit more technical. When I talk about abstractions, then it's about encapsulating or preserving information, as it says here, that is relevant in a given context, and forgetting information that is irrelevant in that context. That's a very esoteric quote, I would say, but abstractions are important because if you don't isolate or abstract from something, then it invades whatever you're working on, and you probably don't want that. Abstractions have a little bit of a bad reputation because they're very often implemented poorly or badly, but they're very much needed, obviously. So I think a large part of what a software engineer should learn in his life and his career is getting better at abstracting. I think a lot of talks here that we've heard here today and yesterday already are also in part about that problem. And an important area of abstracting are, as I said, third-party libraries and operating system APIs. Because you might actually want to switch operating systems. I will talk about portability a little bit later, but let's talk about the more abstract concept of abstraction a little bit more here. So another code example. Again, it's fictional, but I've seen stuff like this all over the place. So let's say you have some program that does something with thumbnails, and then someday some engineer decides, I need to load a JPEG as a thumbnail now. I pull in my JPEG library, and then I just directly invoke libjpeg, which has a C-style interface, and then it might look something like this. By the way, I didn't compile this code. I just wrote it, not from memory, but assembled it. So there's a lot of things happening here in this function. Let's assume it does work, but there's a file name coming in, a JPEG is being loaded from that file name, and then pixels are put into a thumbnail, and the thumbnail is updated and added to a database with a file name. And then the JPEG library is destroyed. While this works, and was probably quickly done, I don't think this is sustainable. I think that's technical debt. And I think this code should probably look something more like this. I think specifically talking about the JPEG library here, there should probably be something like a load image function. It could also be load JPEG if you only load JPEGs, but probably most of the time you don't care if you're loading a JPEG or a BMP or a PNG. You want to load an image very often, and writing this function shouldn't be that hard. Writing this image class shouldn't also be that hard. And another abstraction that is in here is the path. We have std file system path now. Also an important abstraction when it comes to portability. I can tell a few stories about that. And another abstraction that I mentioned here is std expected, which I also happen to like very much. I think error handling in C++ benefits a lot from those things. So try to write the code like this, and I think it's not that much overhead if you are used to doing it like this more than the previous style here, then it will not be overhead for you as much. And this at least doesn't create a lot of technical debt. And load image can now be used by other people. And from what I've seen is a something like this will probably be used all over the code base. If it's big enough, then you will want to have an abstraction like this anyway. So what are my recommendations then? First of all, use abstractions that are available to you. Don't try to invent everything for yourself. There's the standard library. If something can be used from there, use it. There's Boost and so on. So find available abstractions. If you write your own abstractions, make them easy to find. And this goes back to the codebase layout, where if you have a nice folder structure, a nice namespace structure, and good naming and good conventions, then people will find your abstractions. If there's a folder src image loading.h, for example, then people will know, oh, I need to load an image, and you can find it there. This is where the codebase layout again helps. So make it easy to find and create abstractions, and then you will have the benefit of having and reusing those. If you find something that's an old tip that I didn't invent myself, obviously, if you find something that is happening, let's say 3 times or more in your code base, then that probably deserves an abstraction. And when you abstract, you might want to think about portability as a reason to abstract, consistency and maintainability, reducing technical debt. And again, specifically about external libraries, they're often C-style APIs, they're not C++ APIs that you will find there. You want to integrate them into your C++ code base, and just to avoid memory leaks and all kinds of issues, just build a small layer of abstraction around like a C-style API so you can use them in your C++ code without worrying about if you need to use free on this pointer now or not, that you have flying around there from some third-party library. Closely related to that then is a general topic of portability. Now, obviously, if you move from one platform to another, and I know this mostly about from the direction of Windows to Linux, you need to abstract from the platform details. And that, as I said, requires abstractions. And I've seen many code bases and some startups that started out with a pure Windows code base, using Visual Studio, working on Windows, creating demos with a cool machine learning, computer vision project feature. And then, in this case, our company comes along and tells them, great product that you have. We want to use your stuff. It's really great on the technical side, but our servers are running on Linux. So can we have your code base for Linux as well? And then they're like, oof. Yeah, give us 6 months and we come back to you. You don't want to be in that situation, and ideally. And even if you don't support all platforms from the beginning, you can prepare to make it not as hard on you if you have to. Because doing stuff like this retroactively can get really, really hard. There's one code base that I'm aware of where, for example, something simple like the pass abstraction didn't exist. So everything was a string, const char or maybe a std string. But concatenating passes was always done like with just a backslash and a plus sign everywhere. Or finding the file name component of a full pass was done in line with some old school C functions where the last backslash was being found, and if there's none, then the whole string is returned. And then imagine you have this code like literally 200 times or more all over the code base. At some point, I think some engineers should have seen this and said, okay, if you're dealing so much with passes and manipulating passes in our code base, maybe you shouldn't re-implement this everywhere and have the pass separator constant in 1,500 places. There should have been an abstraction. And I can tell you, because I did it, fixing this retroactively was a lot of work and caused a lot of issues, and there's a lot of worries about how we break things. And so use the pass abstraction, don't rely on strings. And that is true for a lot of things where you repeat yourself. I want to shout out Microsoft here a little bit. Microsoft, I have to say, they didn't really do a good job in the past. It's also gotten better, but especially if you start out with your code base on Windows, still, Microsoft Visual Studio doesn't tell you when you do something that isn't in the C++ standard as easily. There's flags that on the compiler level that will tell you, oh, you're doing something that we think isn't part of C++ standard, but we support anyway, like _ super, if ever anybody of you used it to access the base class of a parent class. That's a Microsoft extension of the C++ language. And I've unfortunately seen this used all over the place. Or inline always, for example, is something that Microsoft supported, force inline, sorry, not inline always, _ force inline is another thing, which just works on a Microsoft compiler, but on no other compiler. And if you just don't know, then you might use the stuff, and then you might have a lot of changes on hand if you ever don't use the Microsoft compiler. So I would recommend setting up your compiler correctly, so those things don't work, even if you think you're only on Microsoft Windows, and not use those. So to summarize again, use abstractions to abstract from platform-specific code. Abstract directly to keep it manageable, so don't wait too long. You also might want to isolate platform-specific dependencies pretty early into a separate library, so you can say, okay, this is all my Windows implementation in this library, where I have all my file access and my path manipulation and my multi-threading that is specifically tailored to the Windows API. This all lives there, and this is my other part of the code where it's just my business logic that isn't platform-specific. You might want to do that. CI/CD, I think, is really important here. You might think I'm joking, but again, many startups that I've seen, they just don't have CI/CD. It's like there's 3 guys and they just build stuff on their machines, and they don't even know what CI is, because I don't know, maybe it's different now, but historically this apparently wasn't taught to people as much, or there wasn't as many tools either. Yeah, and if you're on Microsoft compiler, I would recommend to use /permissive-, or maybe even try clinkcl, which is supported in Visual Studio. That will tell you a few of if you do something that only Microsoft allows. Not all of it, but some of it. Next topic, which I think could be also very interesting, maybe less interesting than those before, is interoperability. That might be specific to the code bases that I've seen a lot. I've spoken with a few people and said, it's not that much of a problem, but I want to talk about it anyway. C++ is not a very interoperable language, and by interoperable I mean it doesn't work well on its own together with other programming languages. You need to have a C as an intermediary pretty much always. There's this entire problem of name mangling and call styles for functions and so on. And at least in a lot of projects that I've seen, at some point your C++ code base, let's say it's a library that does one specific thing, will need to be integrated into, let's say, a desktop application, and then the desktop application is implemented in WPF, or it's supposed to be used in some server backend, but the server backend is written in Java mainly, and then you also need to have the ability to have the C++ code talk with the Java backend. And as I said, C is the intermediate lingua franca, as it's called, of interoperability nowadays still. That has its own problem, because C++ isn't very good there. Even though I don't recommend thinking about that too much. I think you should write your C++ code as C++ code. So don't try to think, maybe I need to call this from Java eventually, and then I want to have only C-style interfaces. I would recommend write modern and good C++ code. And then, if you come into the situation where you actually need to have an interop layer with another language, Python is also a big one, then you create that layer, and you create it specifically for the stuff that you need to expose. So keep the surface area minimal, and do that when you have to. And don't put any logic into the interop layer. It's really, really important. I've seen this is a big mistake with C++ CLI specifically, which I recommend don't use it at all. So if you're ever in a situation that you have a C++ code base and it needs to interact with .NET, Microsoft is still supporting C++ CLI on a compiler level, but they want to abandon it for a long time. They just can't because there's too many legacy customers that are using the stuff that tell them, no, we need to use C++ CLI still, we haven't migrated our code yet, but they will kill it eventually. And the reason why this is particularly dangerous is because you can actually write .NET and C++ code in the layer that is C++ CI, which should be only a translation layer. But if you put logic in there, then you have to change your software architecture all of a sudden. You have to move this code one way or the other to get rid of it. And one company that I know of just can't do it. They have a lot of stuff there, and they just fail. They will probably stay there as long as Microsoft supports it, even though they don't want it, and that creates a problem for them. So don't start with that. If you have interoperability layers, then just have pure conversion of types in there and nothing else, and function calls. And you can also use generators for an interoperability layer. Swig is a big one, which I've used quite a few times. It's nice. It can do multiple languages. Not for a foreign code base, but for a code base that I worked in like 10 years ago in my company. We actually had a multi-language SDK, which was written in C++, and we had bindings for Python and for Java, because those were the environments that we wanted to use it in, and those were generated with Swig. For other languages, like C#, there's CPP#, and then there's Boost Python, which also supports C++ and Python bindings. And the only thing that you need to be aware of, you cannot expect that they will work with all C++ features, so Swig in particular, but also CPP#. I had that experience. They're lagging behind. So it's not like just the compiler implementers are lagging behind the C++ standard. Tools like Swig, which are free and open source, so we should thank that they exist, they just can't catch up with all the C++ features that are coming in. So you probably have to reduce your feature set and your ambitions a little bit when you work with those generators. But then it's not much different than having a C interoperability layer. Okay. Another fun one. Localization, here in the context of text and time. So, usually when projects start out, as I said, we have a small group of developers. They have some code page on their machine. They might have a very Anglo-centric view on how text works and which time zones exist and if they need to worry about that at all. But that might not be a long-term good thing that they didn't worry about that. So at some point, text encodings will matter. If you're doing a lot of with strings, a lot of stuff with user inputs, with text files, or whatever, wherever the text is coming from, you will get a file that was encoded in Korea in a Korean code page, and you need to read it. And then if you don't have the infrastructure in place to do that, or to even recognize code pages, then you will suffer a little bit. So I'm not saying you need to do that from the beginning, but you better be a little bit prepared to deal with different text encodings. And there's ways that you can do that. You might also need to output text in different encodings at some point, or just need to know when some internal string that you have somewhere in which encoding it is even, to be able to generate the correctly encoded output. So, and for me, I view it like kind of as portability between cultures and languages of the Earth. So I kind of treat it like an operating system thing, even if it isn't. But that's how I think about it. I don't know if that's useful, but that's how I view it. And unfortunately, the C++ standard, in my opinion, and the language in general, has not been doing well here in that area. I think that's also changing now. I've heard that we will get Unicode support or better Unicode support in the C++ standard. Right now, you probably have to look at operating system APIs or something like the libicu in order to be able to deal with Unicode. Until the C++ standard offers something there, or more than it does right now. And one thing that I also observed is if you don't consider encoding very early, you might run into a situation where you break a lot of stuff when you need to introduce it. So you might need to change APIs that you thought could be stable. I mean, code changes are obvious, but API changes are always bad if it's external API changes, but also serialization in data. Let's say you just store a string in some file format, and then you use this file format, and your customers are already using the file format, but the string doesn't contain encoding information. It might, for example, use whatever the local code page of the system is by default, and then the file is exchanged to another system, and it will try to read it, because it has no other information, in whatever the local code page of that system is. And if you didn't reserve space to also store what code page or what encoding has been used to store that string so it can be loaded properly on the receiving end, then you actually have to change your serialization formats and maybe the data that you've stored somewhere. And then it has all kinds of backwards compatibility problems that you then have to deal with. And so I have some recommendations then. Use UTF-8. It's great. There's a web page called UTF-8 Everywhere, which makes a good case for using UTF-8 everywhere. And also UTC time. So a lot of the stuff that I was talking about also applies to time and time zones, but to a lesser degree, luckily. So I would just use UTF-8 as a neutral text encoding format internally, and UTC as a neutral time encoding format internally. So I have some summary again here. As I said, use UTF-8. UTF-8 is great. I like it a lot. Microsoft supports UTF-8 in your code files so that all your static string literals in your source files are UTF-8 by the means of a compiler flag /UTF-8. On Linux, you get that out of the box by default, but on Microsoft, you need to enable this. Otherwise, it's going to be whatever the local code page is. I would recommend that whenever you receive a string, you convert it into UTF-8 directly. You work with it in UTF-8. And then if you need to have a different representation on Microsoft, if you talk to Windows APIs, for example, specifically, you need to actually convert the string then to UTF-8 16LE, because that is the operating system default for Unicode on the Windows platform. So do that on the fly, or maybe cache that even. You can also do that, but internally I would recommend use UTF-8 and try to use UTF-8 as much as you can. You will just have less trouble because UTF-8 can actually encode all characters of the Unicode standard. So there's Klingon, Korean, Turkish in there, smileys, everything fits in there. And it's still pretty space efficient if you have ASCII characters. It's ASCII 7 characters still fit into a single byte in UTF-8. So most of the time you won't have an explosion of size of your strings, at least as long as we are talking Anglo-centric. Another big one in general related to this, don't use car and wcart pointers everywhere in your code base. For those who don't know, wcart on Windows with Microsoft compiler is 16 bits in size. And on Linux, it's actually 32 bits in size. So you might think, if you're using that, I can encode my strings and store them like this everywhere, and then use operations with this. Actually, they're differently sized, and that is a portability problem. I would say instead, use a string class that can hold UTF-8. Of course, you can use standard string. There's also competing string classes, which with very rich benefits. There's a Facebook string, and just use a string class. Don't use C-style arrays and pointers unless you absolutely have to because of, let's say, third-party APIs. And use UTC internally. So if you use UTC, you can subtract and add and manipulate timestamps, and you don't have to worry about time zones. If you have a timestamp and you don't know what the time zone is or where it's coming from, if it has no information about the time zone, then you might get lots of different issues and bugs in your software if you then make assumptions about a timestamp which has no information where it's coming from. Of course, you can work with time zones, but why would you? Like UTC, Universal Coordinated Time, is pretty simple, and it's similar to UTF-8, and I would hope that you would use it. And of course, still, if for some reason you need to use UTF-16 or 32 because there's performance, then by all means do that, but by default, UTF-8. It's a big one. Yeah, so that's it. It was a very rough overview. I'm hoping that is valuable for a lot of people that don't know all of what I was talking about. And that was my talk. Thank you.
Thank you very much, Nico, for a very interesting talk. We have a question here from Guillaume Dua, who says, great talk, are the slides available somewhere?
I'm sure Jens will make them available. If not, I will make them available. So I don't know how this works. It's the first time that I'm at this conference. But yes, they will become available as soon as somebody tells me how that works.
Thank you.
You said that you could have like documentation inline in your repository. What about figures? Do you have any recommendations for that?
Yeah, that's a difficult thing. I actually like to use YED to create diagrams. If I don't know how many people know this tool. I think it's pretty big. And it's an XML-based format. But figures are a difficult thing. There's also tools like, try to think of a name, where you can create diagrams in code essentially, so describe them. Forgot the name, but there are tools out there that will... Yeah, PlantUML, exactly. So PlantUML is cool, and you can, because they are text formats, you can store them then in your repository as well. So I wouldn't use, I don't know, I've seen people use PowerPoint presentations and draw stuff in there. This is valid then for like 3 months, and then it's useless, usually. Yeah. PlantUML is a good one, and YED is something that I use.
It's also Mermaid.
I don't know this one, but yeah.
Integrates nicely with Markdown.
Ah, cool. Okay, I have to remember that. Mermaid.
Actually, I wrote a library a few years ago, and I really worked hard at the documentation, and it was kind of some kind of Doxygen-based pipeline to generate it, and it generated a lot of HTML pages, which was great, but no, you had to install a variety of tools if you were going to generate the documentation locally yourself. So I generated it, and I pushed all those generated files into source control, into the repository, and I didn't feel good with that, but I would like your opinion on that.
Yeah, I also wouldn't feel good about that, but it really depends on how often you change it. Like, let's say you have a project and you go back to it every 3 months or whatever, and then you change the documentation with the next release, then it's probably not so bad. But if that's something that needs to be changed regularly, because again, we're talking about sizes in Codebase and development teams that are increasing and the problems, I would stop doing that. If it's your personal thing, then okay, it's not as nice maybe, but it's also not terrible. Like a lot of these things that I talk about today really start to matter only when you're getting bigger. And for your personal stuff, it's probably super fine. So.
No, this was work. So.
Yeah, well. As I said, I wouldn't do that then, probably, but yeah.
Hi.
Hi.
Thanks for the interesting talk. I have a question. I frequently observe small pet projects that all of a sudden get users and people are actually using stuff. And you get limited in the decisions you can make, like for APIs, right? Changes to APIs that annoys users a lot. So can you comment on how to deal with growing user bases as well? which
well,
become unhappy. Maybe.
they are part of the problem. So users are a problem, really, because they just fix a lot of things in place. So I also spoke about like file formats. As soon as your users store stuff that is created with your software, you will not be able to retroactively change this as easily, and you will have to annoy your users. And that's why I think it's really important to get the design right, or at least good, from the very beginning, and not just be lazy about it. So especially if you create file formats and if you create external-facing APIs, you should spend a lot of time on that. To design them to be extensible, versioning is another thing. Like in any file format that I would create, for example, on any API, I would include a versioning scheme. Like there should be versions of APIs, because you want to be able to support the old API, the old file format, but also be able to create new things and expand and extend. So there's no way around it. You need to spend time on this. And just being aware of that problem, I think, induces a few people to do that, I hope. So, great question. I don't know if that helped a lot, but I have no better answers than invest the time to do it right and be prepared.
Yeah, it is indeed a hard problem.
Yeah.
Thanks very much for the answer.
Okay, I think we'll wrap it up now. It's 6:15, and
Okay.
everybody might, well, some people might be hungry for.
Thank you.